Good morning, boys and girls, and welcome to math class. Today we are going to be working on understanding area. And yesterday we were working on perimeter. And we know that perimeter is the distance around something. So we're going to do a quick review of perimeter with our math antics. And then we'll get started on area.
Hi, welcome to Math Antics. In this lesson, we're going to learn about an important concept in geometry called perimeter. Perimeter is just a fancy math term that means the distance or length around a shape. But what exactly does the distance around a shape mean? Well, distance or length is a one-dimensional quantity that we can measure with units like centimeters, inches, or miles. That means that perimeter is also a one-dimensional quantity that we can measure with units of length. For example, the perimeter of a shape wouldn't be just 10, but it could be 10 centimeters. Or instead of being just 25, it could be 25 miles. The units are really important when you're talking about perimeter. Okay, but what exactly do we mean by around a shape? It seems like there would be a lot of different ways to go around a shape. Some of them would be short, and some of them would be very long. Well, perimeter means the absolute shortest distance possible around a shape. That would be the distance you'd get if you trace the path exactly around the border or edge of a shape. A good way to see what perimeter is to imagine that you could walk right along the edge of a shape, like this five-sided polygon. Imagine starting at one of the polygon's vertices and then walking along each side until you got all the way back to the point that you started from. The total distance you traveled would be the perimeter of that shape. In this case, if the length of each side of the polygon was 10 meters, the total length you would travel along all 5 sides would add up to 50 meters. Another good way to see what perimeter is to imagine that you could take a shape, like this square, and break it at one of its corners. Then you could unfold the shape until it formed a straight line. The length of that line is the perimeter of the shape. Doing this helps you understand why perimeter is a one-dimensional quantity, even though it applies to two-dimensional shapes like this square. It's one-dimensional because it's the distance of the lines that go around the two-dimensional shape. Okay, so now that you know what perimeter is, how do we measure or calculate it for different geometric shapes? Well, that depends on the shapes. Finding the perimeter of shapes that have
Okay, hopefully that was a really good reminder of what we've been working on in math the last couple of days since we've been doing perimeter. So before we move on, I just wanted to review that perimeter is the distance around something. So if you had a fence, or if you were wallpapering, you would wallpaper the outside with distance around, and that would be the perimeter. All right, so we're going to move on to So now we're going to switch gears. We're going to go from the distance around an object to the actual area inside. Okay, so there's some things that we need to review just to get your mind back on multiplication, because multiplication is going to come into play with area. So we're going to warm up. We're going to be finding the missing products and factors. Okay, so let's do 3 times 4. Think to yourself, what is 3 times 4? Okay, 3 groups of 4. You are correct, 12. So let's think of 7 times 2. So we have 7 groups of 2. They're always equal groups. Hopefully you're coming up with 14. What'd you come up with? 4 groups of 8. Hopefully you came up with 32. And now we have a missing factor. Okay, so now we have 2 groups of something equals 18. So you have to think to yourself, all right, well, If I have 2 of something and my product is 18, what would that number be? You are correct. That would be 9. If you have 3 groups of something equaling 21, so you would break the 21 up into 3 equal groups, and hopefully you would come up with, you are correct, 7. All right, we're still trying to find our missing factor. So we have 5 times what equals 30. So you have 5 groups of something equals 30. So hopefully you're thinking 5 times 6 equals 30. Remember, multiplication is equal groups. So you have 8 times something equals 24. So you have 24 and you have 8. So how many groups would you have of 8? You are correct. You would have 3. 3 times 8. So that would be 8, 16, 24. So we're looking for our missing factor. What times 6 equals 36? Well, you know that 5 times 6 right here, 5 times 6 is 30. So if we add another group of 6, you are correct. 6 times 6 equals 36. And our last one is our 9s trick. So you have 2 plus 7 equals 9. And we know that 2 is 1 less than the 3, so we know our missing factor is 9. So 9 times 3 is 27. Hopefully that has gotten you your brain back on multiplication. I put up a multiplication grid here because I thought if you forgot, you could take the 4 here and you could see, let me get my highlighter. So if you did 5 times 5 and you follow the grid down and it crosses over itself right here. They're perpendicular and they come at a 90-degree angle, all kinds of math terms. How about 3 times 3? So you have 3 times 3 and that would be 9 where they cross. You go down and over and where they cross right here, that would be your answer. So if you've forgotten your multiplication facts, please go back, make a multiplication table, fill it in. We know that it's skip counting. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So you can skip count if you've forgotten your math facts. All right, so we're going to move on to our math book. So what I need you to do, I need everyone to get out your Go Math book, and I need you to open up to page 643. And we're going to go through our math book together. All right, so understanding area. So we've already done perimeter, so now we're going to do area. And let me get my face off of what we need to talk about. So we know perimeter. Let me get a pen here. All right, so we know perimeter is length plus width, and that's a fence. So this would be the distance around. So if I wanted to, let me make a little infinite cloner here. So if I wanted to do the distance around something, let's say my backyard, I would take this fence and I would go the whole way around my yard. And I would count up how many feet, inches, miles, whatever it would be. That would be the distance around. That would be your perimeter. Well, we're not going to talk about perimeter anymore. We're going to talk about area. Area is the length times the width. Okay, area is the inside space, the carpet area, which is why I put a carpet here so you could see that it's covering something. So this would be an area rug that you would put on your floor. So area, think of an area rug in your house, okay? So area and perimeter are definitely different. Perimeter is the distance around, and area is the measurement of square units needed to cover a flat surface. okay? The area to cover a flat surface. And it's measured in square units. We're going to talk about square units. So our question here, our essential question is, how is finding the area of a figure different from finding the perimeter of a figure? So we just discussed that. We know that perimeter is the distance around something, whereas area is the flat part. It's the measurement of square units needed to cover a flat surface. Okay? So it says, unlock the problem. You learn that perimeter is the distance around a figure. It is measured in linear units, which is what our video showed us, that if you took a square, and if you took the square, the outside of the square, and remember he said if you cut it right here, and then you made this all flat, you unraveled it, okay? So think of linear as like a line, okay? So you learned that measuring the distance around a figure, it measured the linear units, or the units that are used to measure the distance between 2 points. So if we did from this point and we went all the way around, okay, that would be the outside. Area is the measure of the number of units squared needed to cover the flat part. So now we're talking about the inside part, the flat part, okay? A unit square is a square with a side length of 1 unit. It has an area of a square unit. So if you have this side and this side, okay, then if you were to cover it, it would cover all of this area. That would be 1 square unit. Okay, so let's look at perimeter versus area. So perimeter, and here's where he broke it apart. Okay, so the perimeter is the distance around something. So you have 1 plus 1 plus 1 plus 1. Okay, so that's 4 square units. To go around something, remember, think of that man walking around a fence line. Okay, whereas the area, we're talking about the inside space. Okay, so let's go over here. And it says use your geoboard. So hopefully you're at the bottom of your book page. This is your geoboard. We don't have rubber bands, but you're going to be drawing. And it says use your geoboard to form a figure made from 2 square units. So I have my square units over here, and I'm going to pull them over. So this is what I want you to draw. All right, so that would be 1 square unit. Okay, so you have 1 square unit. There's 1, and it covers 4 little pegs. So now you're going to do that twice. You're going to have 2 square units. Okay, so now it says, what is the area of this figure? Now remember, area up here, there's a formula for area, and it's length times width. Perimeter was length plus width. So now we're doing the inside. So we're going to have the formula area equals length times width. So right now we are going to, let me put a number right here. So on this side, you have 1 square unit on this side. But if we go to this side, you'll notice that you have 2. There's 1, 2. So we are going to write the number 2. So if you think about it, and we do the formula, which is area equals, and we're going to do length times width. So if you do area equals length times width, and we do area equals, and we multiply 1 times 4. Oh, I'm sorry, 1 times 2. I apologize. 1 times 2. So then we count up 1, 2. We're doing the inside. We have one row with 2 in each row. So that's multiplication. Doesn't that kind of look like an array? And when we did arrays, we would count up how many groups on the side and how many in each group. So there's one group of 2. So 1 times 2 equals, and you are correct, and that would be square units. Okay, so we have an area is one group of 2. 1 times 2 equals 2 square units. Okay, so now we're going to change our rubber bands so that the figure is made up of 3 square units. So let me move me out of the way. So it says change the rubber bands so that the figure is made of 3 square units. So now we're going to go over and we're going to bring our square over. Oops, I need my infinite cloner again. Let me grab him. There he is. So there's 1 square unit. There's 2 square units. I hope you're drawing this in your book. And here's 3 square units. If I can get him over here. All right, so there's our 3 square units. All right, so we are going to put our numbers next to them. So how many do we have on this side? We have one group, and then over here we have one group of 3. So remember, area equals length times width. So we have to remember that. That is so important. And if we have area equals length times width, then we know that we are going to use multiplication. So we want to go to our side and we have one group. We have one group of 3. So it's 1 times 3. And if you count it up, area equals the inside. There's 1, 2, 3. So you have one group of 3. Area equals length times width. So 1 times 3. And that equals, what does 1 times 3 equal? Hopefully you see that area equals 3 square units. So your area equals 3 square units. Remember, perimeter. Perimeter is the distance around something. That's the length plus the width, whereas area is the length times the width. It's an area rug, okay? So let's turn the page and we're going to continue to practice and learn what area equals. So we know that perimeter is the length times the width. It's the distance around something. We are going to continue on and learn area, which is everything inside the flat surface, okay? All of the square units needed to cover the flat surface. So we're going to try this. It says draw 3 different figures that each are made from 4 square units. Okay, so we are going to use, hopefully you guys are going to draw. So I'm going to put 1, 2, 3, and 4. Did everybody draw this? Okay, so we know area equals length times width. Okay, So we have area equals, length times width. So we're going to do area equals, and we want to know our numbers. So how many do we have going down the side? So over here, we see that we have 4 going down the side. And then how many do we have going across? So you should be able to see that you only have 1. So area equals 4 times 1. And what is 4 times 1? So area equals, we have 4 groups of 1. So what is 4 groups of 1? 4 groups of 1, area equals, you are correct, 4 square units. So that's for this one, okay? So we're going to move this out of the way. Oops, let me see if I can get rid of this. Cut that out of the way. Okay, so we're going to move on and we are going to look at figure 2. So if you look at figure 2, I've put 4 square units, okay, into a different shape. Over in figure 1, I had a vertical column that I put my 4 square units. Now I'm taking the same size square units and I'm putting them on figure 2. Please draw the shape that I drew. Now, how can 2 different figures have the same area? So we're going to look at that because the measure of the number of square units covering the figure, if you look right here, 4 square units, 4 square units. So the number of square units covering the figure is its area. So the area is the amount of space that's covered. So you can rearrange the unit squares used in one figure to make a completely different figure, and the area will not change. I'm still using 1, 2, 3, 4 square units. 1, 2, 3, 4 square units. So you can see that it's not changing the size, it's just rearranging them. So I have 1, 2, 3, 4 square units. But it does change the numbers. This was 4 groups of 1, so 4 times 1. Over here, we're going to use the same formula using multiplication, and it's going to be area equals, and over here you can see there's 1, 2 on one side, so it's going to be 2 groups of 1, 2, 2 groups of 2. So the math problem looks a little different. Oops, sorry, I don't need that. So area equals 2 groups of 2. And what is 2 groups of 2? It is 4 square units. So our answer down here is still 4. 4 square units. All we did was arrange the units in a different order and make a different shape, but we're using the same amount of units. So over here, you can see that I took 4 square units from figure 1, arranged them differently for figure 2. Then I took these same square units and I arranged them in a different way. Now this is going to change because we know with multiplication, you have to have the same amount in every group. So this was one group of 4, so that was 4 times 1 or 1 times 4. This has the same amount in each group, so that would be 2 groups of 2, which is 4. But now you can see these don't have the same amount in every group because I took this one here. If I put it here, we could use multiplication, but since I moved it here, now the groups are uneven, so you cannot use multiplication. We know multiplication is repeated addition, so we're not going to do that. Now what we have to do is we just have to add up how many square units are being used to cover this area. So that's going to change from using area equals length times width. We don't have the same grouping anymore, so now we're just going to add up the amount of space covered. So that would be 1 plus 1 plus 1 plus 1. And that still adds up to 4. Okay? And we know we can use addition because multiplication is repeated addition of the same numbers. But since we don't have the same numbers, we're going to just add 1 plus 1 plus 1 plus 1. And that still gives us, hopefully you're writing this in your book, that still gives us 4 square units. Okay? So we're going to go on and we're going to watch our Sharon show, and he's going to explain how we can use different square units for different figures, just like we were doing together.
You know, area is a really, really important idea, which actually involves taking a look at objects that we can draw on the plane, on a flat surface, and seeing how much material we would need to actually fill all that thing in. The stuff inside basically gives us area. So it's tricky business to think about, but let's see some examples where we'll make area meaningful. So first of all, what is area? Area is the measure of the number of unit squares needed to cover a flat surface. So here's, if I were to take a look at this grid, and let's say that each one of these is a 1 unit square, then if I take a look at this square right there, and I take a look at covering it, then in fact, I would require, interesting, I would require one unit worth of material, and so this would have an area of 1 square unit. There's 1 square that I outlined, and therefore the area is 1 square unit. So for example, what if I were to actually extend this picture? If I were to extend the picture and make it look like this, well, now notice that I've got that first unit square, and I've actually got a second unit square, and now a third one. So I see that I have 3 unit squares, which means the area will be 3 square units. 3 square units, 1, 2, 3. So the way we measure area is by seeing the number of unit squares that are required to cover it, fill it up. So let's take a look at a more interesting example. And let's see if I can actually get rid of these things. I think I'm doing a good job. And I'll get rid of all that. And I'll even get rid of this. And I'll even get rid of this. Now, let's have some fun. Let's see if we can draw 2 different figures, each with an area of 10 square units. So all I got to do is draw a picture, and I have to make sure that it's covered by 10 square units. So, and there are lots of answers, by the way. There's not just one answer. There are lots of answers. I'll just draw you one. So one answer would look like this. Let's see if I can do this right now live. Here we go. So what if I draw, what if I draw this? Okay, so I start there, and then I come over, and now I'm going to go up. Now I'm going to make a kind of funny shape thing, right? So let's have some fun. Let's have some fun. We always have fun with math. So let's have some fun with this math. There. Now, suppose that that actually was going to be my shape. Well, then how many square units is that? Well, one way to do that, I'm going to draw a nice version of it right here. Isn't that pretty? Diddle-ding, diddle-ding. I'll put it over here. Diddle-ding, diddle-ding. So all I have to do is now count and see the number of squares. And if I see the number of squares, that will tell me what the area is. And so if I try it, what will I see? Well, let's see. Here's a square, so that's 1. Here's another square, so that's 2. And then I have one square right here, that's 3. One square right here, that's 4. Notice that I'm looking at the squares as just the ones that are being bounded by these 4 dots. So this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10. So in fact, since there are 10 squares here, that means that I have 10 square units. Again, if I have 10 unit squares, that means that the area is 10 square units. So this little drawing I did actually has an area of 10 square units. All I did was count the squares. And just to make sure you can really see that, just to see the squares, let me just put in some dotted lines here. Boop, 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 boop. Boop, 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 boop. And so now I'm going to make the squares all visible. Do you see all the squares? And the squares, right in the center of each square is a number that counts which square it is in my counting. And you see all 10 of them. So now you can see all 10. Okay, well now that was a fun example, but our challenge was to actually see if we could draw 2 figures. So let's draw a totally different one and see if we can now draw a different one. Actually, I'm going to draw one that's going to be inspired by my name. So my name is Edward. It starts with an E. And so let's see if I can actually do a sideways E. Here we go, sideways E. I'm going to start it right up here. And I'm going to come down this time and go over, then go up, then go over, then go down, then go over, then go up, then go over, then go way down, then go over, then go way up, and then go way across. See how it's a sideways E? Now, that will have some area, and we can figure out the area by just counting how many squares that we see there. So actually, I've got a pretty version of that right here. Let me show you the pretty version. So here's the pretty version of it. Check that out. Isn't that pretty? Whoop. Put it right over it so you can see my version and the pretty version at the same time. So let's see. In fact, you know what? Maybe I should just keep the pretty version. Now that you see how I made it, you can see exactly how I made it. And I'll just now put in the pretty version. You saw me do it live. You know I can do it. And now let's see how much area there is there. Well, all I've got to do is see how many little squares there are. So to see that, what I'm going to do is I'm just going to kind of mark off all the little squares, and then we have to count to see how many little squares we have. I'm just marking them off very lightly, just lightly, so that we can see the squares for ourselves. And what do we see? Well, I see here's 1. Here's 2, 3, 4, 5 squares. Then I've got a 6, 7, 8, 9, and then here I see 10. So I see here I also have 10 unit squares, which means that the area is 10 square units. So area, the measure of the number of unit squares needed to cover any flat surface. And here are 2 examples of shapes that in fact have areas equal to 10 square units. Really neat to realize that area is something that we can actually measure and find, and we see how it's connected. We can actually visualize it as if we had a grid all over in our lives, and all we have to do is count small square units. And that's why area is always units squared. And that you see for yourself, namely square units. In this case, 10. Have fun looking at areas all around you, and I'll see you soon.
Okay, so I hope you enjoyed your video. I know you guys love Professor Berger. All right, so back to our area. So as you can see, I showed you how to use the formula and how to count the inside. Professor Berger, he only did the counting of the inside, which is perfectly fine because the units inside that cover the flat surface, that's the area that we're looking for. So we are going to go to your book, look at question number 1. It says, shade each unit square in the figure shown. count the unit squares to find the area. So we're going to go over to our unit here. Hopefully I can get my marker to work. So you should be able to get all of your boxes there. Okay? So then you should be able to go through and count your boxes. Once you have every single square unit drawn in, we should be able to count our square units and count the amount of surface that is covered. So there's 1 square unit, 2 square units, 3 squared units, 4 square units, 5 square units, 6 squared units. So you should have written 6 square units. Okay, we're going to continue. We're going to count to find the area of the figure. So you're going to draw your lines. And then you should be able to count your square units. There's 1, 2, 3, 4, 5, 6. There's 6 square units covering the surface. So you would write 6 square units. 1, 2, 3, 4, 5, 6. Now, if you look up here, 1, 2, 3, 4, 5, 6, you can see that there are 6 square units, but they're arranged differently, just like Professor Berger did when he did 10. So we're talking about how you can use the same amount of square units, but you can cover the area differently. Okay, so let's go to our next figure. So we're going to draw our lines in. Draw them in your book while I'm doing it. And then we're going to go through and we're going to count our square units. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have an area of 9 square units this time. We're going to move on to number 4. Make all of your little square units. And we want to count up the area that is covered by your square units. 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 square units. It's kind of fun. So I'm hoping that you guys get excited and you can draw lots of different figures. You can create grids. You can do artwork where you are using the same square units but creating different shapes using the exact same square units and finding different areas that you can cover with different shapes. All right, so write area or perimeter for the situation. All right, so let's go back up top. Let me get my face out of the way here. All right, so we know perimeter is the distance around. It's the fence, okay? The outside. If you were to do wallpaper. Area is everything that's covered, the units that's covered inside. The square units needed to cover a flat surface, so like an area rug, okay? Perimeter, fence, and then area rug would be area. So buying a rug for a room, would that be the area or perimeter? Think about it for a second, and you are correct. That would be area. So let me get my pen moving. So that would be your area. How about putting a fence around a garden? The outside distance around. You are correct. That would be perimeter. Nice job, guys. I'm really proud of you. You guys work so hard every day, and I can tell from your quiz questions and how you're answering them. I can see which you're struggling in and what topics you are doing a fantastic job, and I'm so proud of you with math. All right, so we're going to keep going. It says count to find the area of the figure. This is on your own. All right, so you're going to take a moment. You're going to go in. You're going to go into your book. You're going to draw all your lines that you need. And you are going to count up your area. Okay, I'm modeling for it right now, what you're going to do. And then you would come up with 4 square units. This is what you're going to do on your own. You're going to pause the video. You are going to complete this, and then you're going to come back and I'll give you the answers. Okay? All right, go ahead, pause the video. Okay, so let's go over. You're on your own. Remember, you're counting to find the area of the figure. So we're looking at the area, which is the space that's covering you using square units. So 1, 2, 3, 4. So hopefully down here you wrote that it covered 4 square units. So we go to number 8 and we count up how much space is covered. 1, 2, 3, 4, 5, 6, 7 square units. We go to number 9. 1, 2, 3, 4, 5, 6, 7. The exact same amount of area is covered, but it's covered in a different shape. 7 square units. Going down to 10. 1, 2, 3, 4, 5, 6, 7, 8. Or you could have seen here that you had 4 groups of 2. 1, 2, 3, 4. And so you could have multiplied 2 times 4 and got 8, 9, 10, 11, 12, and added on the extra square units. Looking over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 square units. All right, so down below, we had to write area and perimeter for the situation. So remember, we've been talking about if it's a fence line, that would be the perimeter. If it's something that's covering like a area rug or a rug, that would be area. So painting a wall would be like wallpaper or a fence. It goes on the outside, so that would be a perimeter. Covering a patio with tiles, that would be like covering the flooring. So that would be the area. Putting a wallpaper border around a room, that would be like a fence going around the outside. So that would be perimeter. Gluing a ribbon around a picture frame. Once you see the keyword, if you're noticing around, that means that it's going to be going around the perimeter. So perimeter is what you would choose. Nicole's mother put tiles on a section of their kitchen floor. So now we're looking at tiles on a kitchen floor. So now we're thinking area rug. The section included 5 rows of 4 tiles. So it's 5 groups of 4 in each row. Each tile costs $2. How much money did Nicole's mother spend on tiles? So if you have 5 rows with 4 tiles, so you have 1 row, 2 rows, 3 rows, 4 rows. There's your, or I'm sorry, 5 rows. And in each row you have 4 tiles. So you have the same amount in every group. So hopefully you saw that you were multiplying. So we want to know how many tiles we have in all. We have 20 tiles. Now it says, how much money did Nicole's mother spend on tiles? Well, it cost $2 for every tile. So you have to think to yourself, what is 20 times 2? So we've been doing 2-digit by 1-digit multiplication. So if you multiply, and I'm going to move this up, move it right over here. So if you do 2 times 0 equals 0, and then we know we do the ones column first. 2 times 0 is 0. Now we go and we multiply the 2 times the tens column. So we do 2 times 2 is 4. And we know that 2 groups of 20 is 40. So they are going to spend, find our dollar sign, $40 on tiles. Each tile costs $2. Now you could skip count down here, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So you would skip count by 2s. But we know if we use multiplication, it's a lot faster because we have the same amount for each of the 20. So we would multiply. We'll move on to the next page. Okay, I hope I gave you enough time. So Juan is building an enclosure for his small dog, Eli. Use the diagram for 18 and 19. Juan will put fencing around the outside. So we know that fencing is the perimeter of the enclosure. How much fencing does he need for his enclosure? Well, when we look back and we think about our previous lessons, in chapter 11, we know perimeter is length plus width. It's the fencing, it's the outside. So hopefully you went around and you counted and you did perimeter equals, and you did 7 plus 3, which I'm just doing around, plus 1, plus 1, plus 4, plus 1, plus 2. Oh my goodness, I'm running out of room. And then plus 3. There was a lot of numbers that you had to do. So you had 7 plus 3, that was 10, plus 1, so that's 12, plus 4 is 16, plus 5, 10, 11, 12, 16, 17, 19, 20, 21, 22. So hopefully you got 22 units, okay? Because if you walked around, that would be your perimeter, the fence line. Now it says Juan uses grass sod. So grass, think about grass. It goes over top, okay, of the ground in the enclosure. They want to know how much grass sod will Juan need. Okay, now here's perimeter is adding all the sides. And we know the area, sometimes you can use multiplication if you can find multiple groups that are the same. So if you look here, there's 7, 7, and 7. So you could do 7 times 3, which would cover all of this area. And so you would do 7 times 3, and I'm sure many of you did that, and you got 21. And then you added 21, 22, 23, 24, and 25. And so your total, so you did the 24 plus that 4, and your area equaled 25 square units. And I know my stylus isn't as good as my finger, I don't think. So it would be square units. Okay. It's tricky stuff. All right, we're going to go down below. Let me get my eraser and get rid of some of this stuff. Okay, so you can see. All right, so it says draw 2 different figures, each with an area of 10 square units. So you had to draw a picture of something that had 10 square units, okay? So you could have gone down 5, 1, 2, 3, 4. 1, 2, 4. So it goes 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we know that would be 1, 2, 3, 4 and 1, 2, 3, 4. So we know 4 times 4 equals 16. So, oh my gosh, that's too many. We can only have 10. So I need to go in and I need to erase, let's see, I need to erase 6. So if I got rid of those and those, I would have, and let me count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. All right, so now I have 10, and it kind of looks like a chair. So I have to draw something else that has 10 square units. And I think I'm just going to draw using some lines here. So there's 4. So there's 4. Hopefully you guys have something really cool drawn. Maybe if I go out, let's see what I end up with. Let me use my pen. I might need to add some more. 1, 2, 3, 4, 5, 6, 7, 8. I need to add 2 more boxes. Okay, so I'm going to just add it straight over here. So there's 8, 9, 10. And my chair is a little bit different this time. All right, so drawing different figures, but with the same area. All right, you can use multiplication like I did, but then I was too many, so I needed to erase because I was only allowed to have 10. Okay, so I could have done 2 groups of 5 if I had measured it off correctly. That would have been cool. Or 5 groups of 2. All right, so there's lots and lots of different ways you can come up with it. All right, and we know in math we can use, we can draw something and then we can make changes to it because there's constantly, you have to make changes and adjust to find the right answer. All right, so number 21, what is the perimeter of the air and the area of this figure? So hopefully you did the distance around and you counted all of the sides like you were running around this figure. And hopefully you got 24 units. And then the area, if you would have counted all of the inside square units, okay, you would have gotten 21. All right, we're moving on. So this is your lesson, your practice and homework here. Count to find the area for the shape. So hopefully you made all of your little square units and you would get 6 over here. Hopefully you did all your square units and you counted up and you got 4. And then all of your square units, you counted up and you made them and you would have gotten 5. All right, so now are you going to use area or are you going to use perimeter for each of these questions? For carpeting a floor, so putting carpet over top of a long area of flooring, what are you going to use? Are you going to use area or are you going to use perimeter? You are correct, you are going to use area. For putting a fence around, the distance around something, you are correct, you would use perimeter. All right, so over here, you were to, Roberto is building a platform for his model railroad. What is the area of the platform? Hopefully you went in and you counted all of these, okay, and you came up with 12 square units. Roberta will put a border around the edges of the platform. So now we're going around, the distance around. So hopefully you came up with 16 units. Draw a rectangle using dot paper. You might not have dot paper, so you do not have to do that. I know there are some questions we cannot do because we're not in school together. All right, so our lesson check. Josh used rubber bands to make the shape below on his geo board. What is the area? Area is everything inside. Hopefully you came up with 3 square units. Remember, SQ period units. Wilma drew the shape below on dot paper. What is the area, which is everything that is inside being covered? And hopefully you came up with 5 square units. For your spiral review, which goes back and talks about everything we've learned in the past, Leonardo knows that it is 42 days until summer break. How many weeks is it until Leonardo has summer break? So there are 7 days in a week. They gave us the whole number. They gave us how many days in a week, so we know we would be breaking it apart into equal groups. So 42 divided by 7, hopefully you got 6 weeks. Nan cut a submarine sandwich into 4 equal parts. We're equally dividing and ate 1 part. What fraction represents the part of the sandwich that she ate? That would be 1 of the 4 parts, 1/4. Wanda is eating breakfast 15 minutes before 8. What time is this? So we have talked about time. So we know it's 15 minutes before. So you have to think, okay, well, what hour is it if it's 15 minutes before? So we know that hour is 7. So we know that it would be, in what is 15 minutes before 8? 7:45. So hopefully you got 45. And I know it's not working, so I have to write it 7:45. A little messy when I have to write it. All right, so let's go to our last one. Dick has 2 bags of dog food. Each bag contains 5 kilograms of food. We've been talking about metric weight, okay? So we know it's kilograms and grams. We know a gram weighs about as much as a paper clip, okay? You put a paper clip in there. Are you using any muscles? No, but if you had to lift something that's a kilogram, we know that's 1,000 paper clips. So you have to use more muscle. So how many kilograms of dog food does Dick have in all? He's got 2 bags of dog food. Each bag contains 5. So we've got 5 in this bag, and we've got 5 in this bag. So think to yourself, 5 plus 5, that gives you 10 kilograms. All right, so I hope you enjoyed today's lesson. I do have a video that goes on and talks about area in a little more depth. So if you want to continue listening, this is a Math Antics video, and he's really good. The Math Antics is good, and he challenges us today because he does not only our rectangles and our squares, but he goes in to talk about triangles. And I think you guys are all so smart, and I know you love to challenge yourself. So I hope you enjoy this video, and if you don't go on, just know that I'm very proud of all your hard work, and I look forward to seeing you tomorrow. All right, so enjoy this video.
Hi, welcome to Math Antics. In our last geometry video, we learned that all 2-dimensional shapes have a 1-dimensional quantity called perimeter, which is basically the outline of the shape. In this video, we're going to learn that these
It looks like we're having technical difficulties, so I'm just going to add it on to a separate video list for you. All right, take care.